So, hi everyone, am I audible? Am I audible? Anyone please confirm by typing in the chat box. So, we'll have this session from 6 to 8. So, let's wait for a few more minutes so that everyone can join. So, hi everyone, let's start today's session. I'm Rupesh Kumar, and these sessions are held every Fridays, 6 to 8 p.m. So, welcome to today's session on problem solving through programming in C. I hope I am audible. If you have any queries, you have to type in the chat box. That's the only way you can communicate with me. And at any instant, if you feel that your network is my screen is not visible, or there is some network issue, just inform me by typing in the chat box. Fine, everyone. So let's start today's session. And allow. Is my screen visible? Anyone please confirm, is my screen visible? Great. And I hope my voice is also clear. So during this week, you saw about a few basic things about functions in C, and then uh, searching and sorting in arrays. Fine. So let's see if some few tutorial problems on them. So first problem, what is the worst case complexity of insertion sort? Everyone, are you familiar with the idea of insertion sort? Everyone, are you familiar with the idea of insertion sort? Fine. So just 1 second, guys. Hmm. Yeah. So yep. Uh, let me do one more thing. And here's 1 second, guys. There is some issue on my side. So 6 8 9. Yeah. So is my screen visible? Everyone, please confirm. I hope it should be visible. Is it? Great. So yeah, let's get back to our problems. Hmm. So what is the worst case complexity of insertion sort? 1 second. One. Hmm. Uh-huh. So what is the worst case complexity of insertion sort? So let's start. Hmm. So I hope every one of you is familiar with insertion sort. So let's say we are given an array, a list of values. Fine. And now you want to sort it using insertion sort. So what's the way you do it? Um, so how do you do it? So it's like sorting a deck of cards. So I hope every one of you is familiar with the idea of sort deck of cards. So what do we do there? Let's say you are given cards and you have to sort them according to the numbers, and you have numbered cards, numbers from 1 to 10. So what do you do? You keep the card in your hand, in your left hand, and you start checking the cards that you are that you the cards that you have in your another hand, and you put it in the place where it belongs. So insertion sort is inspired from that idea itself. For example, let's say we had some set of values like this. The cards were looked like this. Hmm, fine. So let's say the cards look like this. What would you do? You would start from the second element, and you will put it in the place at which it should have been if the cards were in a sorted order. So this will go from here to here. So you will swap these. So your new array becomes hmm, so your new array becomes 1, 2. Now you have two sections in your card. One is the sorted section, the left hand side, left one, and the unsorted section, which is the right section. Fine. So now what you do, you repeat the same process. You take one card from the right section, which is the unsorted section, and put it in the place where it should be. So you see, 3 is not greater than less than 2. So 3 as it at its right place. So now you check 6. 6 it is at its right place because it is in the best position, sorted position for 6 is after set 3. Now 5. When you compare 5 with 6, you see 5 is not so at its correct position. 5 it less than 6. So now what you do, you try to find the best position for 5. So you again go back to one place, you go one place more back, and you go back 3. You find out 3 here, and you say that 5 is greater than 3. So the correct place position for 5 is in middle of 3 and 6. So you have to insert 5 here. So how can you do it? Simply swap 5 and 6. So you will get this array 5 here and 6 here. Again, you will see 9 is at its correct position, but 8 is not, and then you will swap them. So you will get 8 and 9. Fine. So this is the idea of insertion sort. I hope everyone is this was clear. And the thing is how to compute complexity. So the question says what is the worst case complexity of insertion sort? So how to compute this worst case complexity? So every one of you, are you familiar with the big O notation? What is the complexity analysis? So no one is responding to my query question. So anyone please respond. Am I audible? Fine, I see some thumbs up. So anyone please type in the chat box just once. Yeah. So I'm just explaining the idea of big O notation. So big O to come big O, which is used for computing computational complexity of algorithms. So this is the question that is asked here. So, so yeah, the question is, what do you mean by worst case complexity of any algorithm? So let's say you have some algorithm that uses function that computes function f of x. Fine. So let's say f of x is some algorithm on the input size x. Fine. X is the input size here. Now let's say you have another function gx that is strictly bigger that is strictly greater than fx, right? So let's say this is our fx function. This is the algorithm that we are comparing. Fine. Fine. Then what is the big O of fx? Which is let's define a function gx such that such that let's define this function in orange, call it gx. Fine. So we say fx is big O of gx. Basically, from here we can say, let me erase this. Ah, yes. So I am saying fx has a worst case complexity, which is big O of gx. Fine. What does it mean? This means fx is strictly less than or equal to cgx. Fine. As you can see in this graph also. So every input at every value of input size, fx is strictly less than the function gx. So for any value of x, for any value input size, fx will always take. So this is time basically. On the x-axis, y-axis, you are capturing time. Fine. So when you talk about time complexity analysis, so we are capturing time here. Or there is another analysis that captures space, so that is space complexity. But let's talk about time here. So at any size of input, the fx will always be take less time than gx. Then gx is said to be big O. So then big O of fx is said to be gx. Fine. So this is the definition of big O notation. And how to find the big O notation? It's like we have to define a function that is always greater than the function that you are observing. So for example, in case of insertion sort, what you are doing for each step here, sorry, yeah. So for each card here, what you are doing, you are checking it with, so let's say we were at the value 1 here. So what you are doing, you are checking with uh one element here, and so you are comparing these two values, and then swap or not swap, it depends upon the value. So you swap here in this case. Now you again for 3, what do you check? You check 1, 2, 3. Now let's take an example of worst case scenario in insertion sort. So everyone, are you following what I'm explaining here? Am I audible? So everyone please confirm that you are following whatever I'm explaining here. Otherwise the sessions are useless. Yeah, fine. So let's talk about worst case scenario for insertion sort. So what is the worst case? If you want to sort an array, what is the worst case that you can think of? So let's say you have a deck of cards. What is the worst case that you can think of? This is the worst case when the array is in on descending order and you want to sort in ascending. Fine. And what we said, our question asks for worst case complexity. So what is worst case complexity? We have to find a function that takes or that always takes more time than the function that we are observing. That is, we have to find some function that in terms of input number of size of array here. So for this array, the size is n 9. Fine. So we have 9 elements in this array. So size of the array is 9. Fine. So we have to find a function for yeah, x is 9. So let's not call n here. Let's use x here. So x is 9 here. So basically for 9 elements, we have to find a function that will always take more time than the insertion sort algorithm. Fine. So let's try to find some bounds to this. And this is the worst case that you can get when you want to sort in ascending. You have an array in descending order. Fine. So let's start sorting this array. So now let's start with the second element, which is the first index. So let's compare 8 and 9. Fine, everyone. So you know that 8 is less than 9. So 8 is not in its correct position. So what you do? You insert it in its correct position. So what is the correct position? You put it at this location and at index 0. Now you know we don't have any elements before that. So you don't have any element before 9. So you don't need to go back and search any more elements. And you know that the correct position for this element 8 is index 0. Now how to put in 8 array element 8 at the index 0? You swap the value of the value uh, of the current index that we are trying to look, that is index of the element 8, which is 1, with the value present in the target index location. So what is the correct position for that element? So 8, for 8 you have to swap between the index values 0 and 1. So you get 8 here and 9 here. Fine. And let's start counting the number of swaps. Every time the number of comparisons we are doing and the number of swaps we are doing. Fine. So yeah. Okay, let me do thing. So we have to track two things, number of comparisons and number of swaps. So let's see which is what is the worst case scenario here. Fine. So, and I will be using unary one to come set the number of. So we have compared once and we have done one swapping here, right? Now we have this sorted array 8, 9, and now we have the right section of the array, and we again need to do the same. So you check 7 and compare its value with the previous element. So what is the value of 7 here? So you compare 7 with 8. Fine. So you compare 7 and 8, the values of these two elements. Fine. You compare the value of 7 and 8, 7 and 9. So you see 7 is less than 9. So no, this is not the correct place for 7. Now again, you go back and you have to find the place at which you have to place 7. You just don't need to swap right now. Fine. So so you have to place it. So now when you have a sorted array and you are shifting one element from the right hand side to from right towards the left, you know that all the elements will be shifted towards right by one position. Fine. So now how to do that? You need to swap 7 with 9 right here. So 9 will come here and will 7 will go there. Right. Right. Now what you have done? You have done one comparison and one more swapping. Now, again, you have to find the correct position. We have not finished yet. We need to find the correct position for the element 7. So now we will compare 7 with 8 with the element present in before 7, the indexes before 7. So you compare 7 with 8 again here, and you see that 7 is less than 8. So you have to swap them. So 7 gets here and 8 gets here. And your number of comparisons and number of swaps again increased. Fine. Now again, you want to, so we are done till here. Now the array that we have is, the array we have is 7, 8, 9, and then 6 and so on. Fine. So now these entries are null. So these are the correct entries right now. And then 6 and so on. Now again, 6 is less than 9. So you swap these, then you swap 6 with 8, and then swap 6 with 7. So you have three more swaps and three more comparisons, and ultimately you will get the values like this: 6, 7, 8, 9. Fine. So now you can you observe the pattern what I'm doing here? So it's like sorting a deck of cards. You start taking cards from your right hand and start putting them at the right position. So every time you want to put 6 or any element to its correct index location, you need to first find out the correct index location. And after you have found out the correct index location, what you can do, you can shift the elements by one index to make space for that element. And for shifting, what you can do, you can simply do swapping between two neighborhood elements. Fine, nearby elements. That works fine. Or any other way, you can also do this in other way also. You don't need to do swapping here. So let's ignore this swapping here. We don't want to do any swapping here. Now let's say I don't want to do any swapping here. I know that I have to shift the element towards right. What I can do, I can create a temporary variable t, the current variable, and at t I can store the value 6. And now uh, let's say, yeah. So let's not do swapping here. Let's what we can do. Let's see. 7, 8, 9. For 8 and 9, you need to swap these because 8 comes here and 9 comes here. For 7, the correct position is index 0. 1, 2, 3, 4, 5, 6, 7, 8. So for element 7, the correct location is index 0. So what you can do? You can store 7 in the temporary variable t here, t equals to 7. And now what you do, you shift all the elements towards right by index 1 up to index 2. So you shift this 8 and 9 towards right. So you shift 8 to here, shift 9 to here. So you get 8 and 9 here. And now at index 0, you can put 7. Now again, you check 6. 6 is less than 9, 6 is less than 8, 6 is less than 7. So 6 has to be placed at index 0. So what you do, you shift all these elements by one place towards right. You store t equals to 6 in a temporary variable, and now you put 6 here at index 0. So you get 6, 7, 8, 9. Either ways, what are you doing? How are you finding that 6 has to go to index 0? You have to compare all the elements up to index 0. So you have to compare 6 with the index 2, with index 1 and index 0. Now again, when you get to the value 5, you again know you have to compare the index value at in 4, the position at index 4 with index 3, index 2, index 1 and index 0. And then you will get this array: 4, 5, 6, 7, 8, 9. Now for index 6, you compare with 5 with index 6, you compare with previous 6 values and then you swap. So you get 3, 4, 5, 6, 7, 8, 9. Again, with index 7, you compare with previous 7 values, and for index 8, you compare with previous 8 values. Fine. So what happens at the last? You get this sorted array: 1, 2, 3, 4, 5, 6, 7, 8, 9. But now what we were asked? We were asked what is the worst case scenario? How many time? What will be the total time that it will take for our algorithm to compute? So, and we want to find a function that is strictly bigger than that value. So for the last index, so let's start doing this analysis. So we know the pattern, right? For the element at the last index, we did 9 minus 1 equals to 8 comparisons, right? Everyone, I hope I am right. Yeah, are you? I hope every one of you is getting this, what I'm explaining here. Right? Now, for the element at index 7, what we did? We did 9 minus 2 equals to 7 comparisons. Fine. Similarly, when you track this, when you did do a bit of bookkeeping, and you will get to know that for the element at index 2, index 1, we did 9 minus 8 equals to 1 comparison. Fine. Now let's try to. So now we have a scenario when we had a worst case scenario when we had to sort in ascending, but the array was in descending, and we use insertion sort, and we saw that for this case, the total number of comparisons that we did for each element is 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 1, which can be given at 8 into 9 by 2. Fine. 6. Let's generalize this for array with n elements. What will be the answer? Number of comparisons would be n minus 1 into n divided by 2. Am I right, everyone? Do you follow what I'm saying right now? Is this clear, everyone? Please type in the chat box if you have any doubts. It's literally basic things. So yeah, I could have given the correct answer like it's order of n square, but I wanted to show you guys like how to do this. So you should know, understand, try to understand how to compute these complexities on your own. And later on, this is a very brief introduction to big O notation, but yeah, there are more things into this. But right now, I will be able to explain this only. But yeah, I hope is this clear, everyone. Did you also what you were able to follow how many comparisons we were doing? That is fine, right? Am I audible? No one is responding, so I don't know what is happening. Hello. So no one is here. Like, if you don't follow, you can ask me. I will explain again. It's really simple. Hello. Yeah, thanks, guys. So I hope this is clear, no? Uh, so you guys are present here, so it should be clear, right? You are able to understand how it became a sum of 1 to 8, total number of comparisons, and then how can you analyze it to array with n elements, which is n into n minus 1 into n plus by 2. So I'm using the formula. So you simply have to sum 1 plus 2 plus 3 plus, and you have to keep doing up till n minus 1, n minus 2 plus n minus 1. And when you add this up, you will get this answer, right? I will write the code at the end of this session, so don't worry, Stravish. Try to understand this. This is a really good thing, and this is really basic that you need to understand. Fine. So now, when you see the number of comparisons, it would be n minus 1 into n by 2. So when you add these integers, you will get the sum is this value. Fine. Now, what I said we have to find the function gx, which is strictly greater than fx every time. What is x? X is the size of the array. Fine. So let's replace n with x. So this is x minus 2 and x minus 1. Right? So the total number of comparisons is x minus 1 into x by 2. Everyone do agree with this? I hope by now. Now what I'm saying is I want to find we need to find gx such that, just a second. Hmm. Such that fx is less than or equals to gx. Now you have a function that looks like this. If I write it, you will get a function like this: x squared minus x by 2. So this is this function, right? Now you know that this function is always less than equals to x squared. Do you agree with this, everyone? So let me draw a plot: x into x minus 1 by 2. So x equals to 0, there's a root; x equals to 1, there's a root, and at its minimum, what you get? So n equals to 0, to x minus 1, x equals to half. You get the minima. Value is minus 1 by 2 into 1 by 2. So 1 minus 1 by, this is gx. Yeah. So now you will see that this fx, this is fx, and this is gx, right? And gx is always less than fx is always less than equals to x squared, and that's true. Fine, everyone. So the answer for this problem is order of n square. We were able to find a function which is less than equal, which is strictly greater than x fx. So correct answer is option D. Option D is correct answer. Right, everyone? Do you have any doubts? Please type in the chat box. So there is some constant applied here. So you need this constant always. Fine, everyone. Is this clear? Do you have any doubts? So just one small thing to note here is that the fx has to be less than equals to some constant multiplier of gx, right? So when you look at this graph, no, you will find that gx will go less than fx for some point, but when you multiply some constant multiplier here, so you will always be able to find a c, the value of a constant that will ensure that fx is less than equals to gx for every value of x. Right, everyone? If you have any doubts, please type in the chat box. And also, yeah, for this program, we know that the number of elements cannot be negative. So the graph that you will find will look like this. So now this goes from here. Oh, now this is your gx, right? And this is your fx. So So this is how your function goes like. So fx is always less than equals to gx, right? Anyone do you have any doubts? Please type in the chat box, or I can move on to the next question. I hope this is clear. Please pay attention to these basics. Sneha, is this clear? I guess this is clear to everyone. So this is a very basic thing that you learn when you start analyzing algorithms. So you start from here itself. This is the first step where you every time you want to define an algorithm, you want to design it most efficiently. What is the most efficient way to design an algorithm, and how to check if the algorithm is efficient or not. For that, you need to you need to understand a metric. What is the metric? Metric, like what is the way to define if the algorithms are efficient or not? How to compare two algorithms, the efficiency of two algorithms? You can compare that using this complexity analysis. And this is one of the most widely used big O notation that I've explained here. If you have any doubts, please go back to the lecture and try to understand this. Fine. So let's move on to the next question. Binary search is most useful when the array is question mark. So everyone, I hope you are familiar with the concept of binary search. So let's say let me change the problem statement. It has binary search is useful when the array is right. So we all know how to do binary search, I hope by now. So let's say you have elements 1, 2, 3, 4, 5, 6, 7, and you want to check if value 3 is present in the array or not. You go to the midpoint, which is 4. You compare 3 is less than 4. So you can discard the right hand side of this array, and you only need to check the value of 3 if it is present in the left hand side. So, right. Now again in this array, you go to the midpoint, you get the value 3. Now the question is, when you can do this? What is the when you can actually do this? When you can discard the half part of the array for searching? You can do this if the array is sorted, or sorted in ascending order, or sorted in descending order. So the correct answer is options A, C, and D. Right, everyone? Do you have any doubts? Please type in the chat box. If you have any doubts, please type in the chat box. So I guess no one has any doubts. Let's move on to the next question. Question number 3. Given an array and key 56, what are the mid values corresponding to the array elements? Mid values generated in the first and the second iterations in a binary search. So let's say we are trying to do binary search or an sorted. So what are the steps in doing binary search? Check if it is sorted or not. So you have to check sorted or not. And you know that yes, it is sorted, right? Let's check. Yeah, 21 less than 33, less than 56, less than 59, less than 64, less than 91, less than equals to 91, less than 100, less than 105. So you can see the array is sorted. Yeah. So this checklist passes. Now, if you want to do searching in this array, you want to search for an element if it is present in this array or not, you can directly use binary search. There is no need to do linear search here. Right, everyone? Now, what are the mid values generated in the first and the second iterations in the binary search? This is the question. Now your key is 56, right? So the key value is 56. So you want to check for the value 56 if it is present in the array or not. Let's solve this. So let's get the indices of this array: 0, 1, 2, 3, 4, 5, 6, 7, 8, right? You have 9 elements, indexes 0 to 8. So what would be the mid one? Mid value, mid index, 8 plus 0 by 2, which is 4, everyone, right? So now, so first mid index is 4 and the value is 64. Now, 56 is less than 64, right? 56 is less than 64. So what you do? You discard the right hand side of this array. So the right hand part of this array from this searching. So you discard this part, right? Oh, okay, let me not just do this here. It's not good. So let me copy this array and then let's do this. Hmm. Right. So we have this array and we want to search for the element 56 and the indices are 0, 1, 2, 3, 4, 5, 6, 7, 8. The mid index is 4, index 4. 56 is less than 64, so you have to check in the left hand side section of this array and you have to discard the right section of this array, right? So you won't find the value in the right half of this array. So you have to only look at these values 21, 33, 56, and 59. Now again, this was step 1. Now in the second iteration, what you do? You will again get mid index equals to, what is the value of mid index? The value is 3 plus 0 by 2. So, so 3 plus 0 by 2, which is 3 by 2, which is 1, right? So the value at this location is 33, and we know that 56 is greater than 33. So now the question is, what are the values that you will find? So 64 and 33. So I guess there is no. Uh, guys, just a minute. Yeah. So I guess there is no other option. So let's change the option C, and the correct answer is option C. Right? 64 and 33. Right. So I'll be here in a minute. Just a minute. Yeah. Everyone, is this clear? If you have any doubts, please type in the chat box. Option C is correct. So this is how you do what we call it, binary search, right? If you have any doubts, please type in the chat box. If you have any doubts, please type in the chat box. Anyone? So someone wants me to explain it again. So let's do this again. Yeah. So what is the first thing whenever you want to do a binary search? You check if the array is sorted, and now we identified that the array is sorted, right? Now, what you do? What does the algorithm say? You start checking the indexes. So you have this. So I have this is visible to all, right? So we have this array and we want to find the mid values for first and second sorting iterations, right? So we have index 0 here, index 1, index 2 here, 3, 4, 5, 6, 7, 8, right? Now let's define something. Let's define one thing. How we compute the mid val, mid index. Mid index is equals to last index. Basically, you will take last index plus first index, right? First index divided by 2, right, everyone? So this is the formula for computing the mid index at each iteration. And if it is not an integer, you will take a floor, right? So you just take a floor of this. So you can take floor of this quantity. Last index plus first index divided by 2. This is the formula for mid index. And how do we do binary search? So we start from the first element. So we have to check for the value 56. We want to check if the value 56 is present in the array or not. So let's start with our first iteration, iteration 1. So I'm writing in green. This is iteration 1. Please pay attention. I won't be explaining this question again, right? So what is the value of mid index? So yeah, so let me get some space here, right? So this is mid, the values of mid indexes are here. Then the value would be, I will write the value here, and then comparison will be done here, right? Let's create a table. Comparison would be done here. So let's create this table, right? These are the columns and the rows tell us the iteration number. So this is iteration 0, this is iteration 1, right? So this is iteration number 0, 1, 2, right? So let's create this table. So at the first iteration, we have array with indexes 0 and 8. So what is the last index? 8 plus 0 divided by 2, you get mid index, the value of mid index to be 4 here. What is the value stored at this index? The value stored is 64, right, everyone? So the value stored here is 64. Now you know that 56 is less than 64, right? 56 is less than 64. So now what you do, you have to discard the section right hand section of this array because the value cannot be present in that half, right? You have to only search for the value in the first half because the array elements are sorted and the value at the midpoint is greater than the value that you want to search for. So you want to search for in only the half of the array, first half of the array. Now let's look at this section of the array. Let us look at the interesting section of this array, right? So let us look at these values. Now this is iteration number 1. So yeah, let me just correct this. I was just using index notation here again. So so this was iteration 1. Then let's go to iteration number 2. Now for iteration 2, you have the array 21 to 64, the last array 21 to 59. Now, what is the last array value? Last index that you find, last index is 3 and the first index is 0. So the value would be floor of 3 by 2, which is floor of 1.5. Floor of 1.5 is 1, right, everyone? So you get mid index as 1, the value is 33. Now again you see 56 is greater than 33. So now if 56 is greater than 33, you know what to do. You know that the part of the array less than 33 is not useful. So you remove this element, right? You don't need to search there again. Now you get an array consisting of how many values? How many elements? We get an array containing three elements, 33, 56, and 59. So let's extract, just for clarity, let's take this array out from here and look for the value. So what is the array now? We have 33, 56, and 59. And it was sorted earlier, so it will be sorted now also. Now the index values are 0. The index values are 0, 1, and 2. Right, everyone? Now, what is the mid index? 2 plus 0 by 2, which is 1. Floor of 1 is 1. So you put 1 here. What is the value here? 56. Wow, you got the value. So we know that now 56 is equals to 56. So now what we need to do? We need to exit. Exit. And in just only 3 iterations, you get the answer. And the question is, what are the mid values corresponding in the first and second iterations? So mid values are 64 and 33. Option C is correct. Right, everyone? Now, do you have any doubts? Anyone? Rakshita, Shravish, anyone? Right. I hope this is clear to everyone. Now let's move on to the next question. Consider the array A equals to 100. So yeah, there is one more doubt. So let me take that. Yeah. When calculating the second mid, we don't count the first mid index as an index. Yeah, that's right. So every time. Okay. It depends upon the algorithm, whatever algorithm you are using, service. So, for example, in this case, what I was doing, I'm saying that the left half of the array is found by the indexes before the midpoint, and the right half of the array is made up of the indexes, including the midpoint and the right half of the array. Right? This is what I was assuming for this algorithm. Right? And thus, when first I found 64, I discarded the right half, which included 64. But when I found 33, I discarded only the left half that included 21. I did not exclude 33. Right? Why? Because because I was assuming that the right half is made up of the mid index plus the values after the mid index, and the left half is made up of the values indexes just before the mid index. Is this clear, Ravish? So it really depends upon the implementation, whatever flavor you want to give to the mid index value, right? Service is this clear? Yeah, right. And someone wants me to look at question number two. We will get to it after the session, or you can look into the videos again. Now, let's get to question number four. Consider the array A equals to 100, 10, 11, 24, 5, 1. Apply the insertion sort to sort the array. Consider the cost associated with each sort is 25 rupees. Let's call it each associated with each comparison is 25 rupees. What is the total cost of insertion sort for sorting the entire array? So let's go ahead and start doing the solving this problem. So we have to do insertion sort on this algorithm on this array. So we have the array 100, comma 11, comma 24, comma 5, comma 1. So we have this array, right? We have this array, and we want to do insertion sort on in this array. And for every one insertion, for single insertion step, so let me for each insertion step, let me each insertion step is 25 rupees. What will be the total cost? So what is the insertion step? So by insertion step, what I'm saying is I'm saying the total number, one insertion step contains two steps: comparisons plus swapping, right? So total number of comparison plus swapping, that includes one insertion step, and that costs 25 rupees. The question is, what is the total cost of insertion sort for this entire array, right? So let's start doing this, solving this problem. Hmm. So we all know how to do insertion sort. So we start from the index value 11 here, index value 1 here. So let me just define the index values. So index values are 0, 1, 2, 3, 4, right? Now you, oh, sorry. Ah. So now you start from the values, index 1. So what is the value at index 1? 11. So let's do some, well, let's do the comparisons here, right? Let's track this here. Let me track the, what is the, what we call it? Insertion step. Yeah. So let's say, uh, let's call it index, current index, right? The current index that we are processing, current index, right? So let's start with the index 1. So now we are processing index 1. The value is, um, so we are processing index 1. So let's call index here. What is the value? And target place, right? Target position or target index, right? We compare, find the target index and put it there. So this is three step. These are the three steps that we follow. So let's start doing this and let's count the number of insertion steps. What is the insertion step? Comparisons plus swapping. So for index 1, the value is 11. And what will be the target value? Target index. What is the target index here? Anyone? Please solve this problem with me, guys. So be with me for this problem. Right? So we have it, we are at index 1. The value present at that index is 11. And now what we want to do? We want to find the target index location at which this value should be actually present in the array if the array was sorted. Anyone, do you know the answer for this? Please type in the chat box. So if you solve this with me, no, you will be able to understand instructions at very best. You don't need to. You will be able to solve these problems very easily on your own. Please give me the answer. Like, right? Yeah, you are correct, Service. The correct location, index location for this is location 0, index 0. So what is the target index? Target index is 0. So what we do, we swap this and you get the array 11 and 100 like this. So what is the total number of comparisons? Total number of insertion step? We have done 1, right? So let's track these also. Insertion steps. So we have done 1, right? Now move further. Yeah, we have done 1 insertion step. Now the next index value that we want to observe is index value 2. The value is 24. What is the target index? What should be the target index? Anyone? Please answer. Yeah, right, Rakshita. Yes. So the target index is 1. So now what you do? You swap these values. You get 24 here, 100 here. Now the total number of insertion steps that we have done is 2. Now let's observe the index value 3. So what is the value at this location? 5. The value is 5, right? Now what is the target index location? Anyone? So what is the target index location here? 0, right? 5 is smaller than 11. So you have to put it at index location 0. So you swap it. So 5 comes here, then 11 goes here, then 24 goes here, and then 100 comes here. Now the index value 4, right? What is the index value at this location? 1. What is the target index? Anyone? You know the answer, right? By now you know the answer. So the target location is index location is 0. So again, you need to shift all the values by 1 towards right, 24, and finally you get your sorted array, right? 2, 3, 4. So how many total insertion steps you do? You do 4 insertion steps. So what is the cost? Option D, 100. We need 4 insertion steps. Each step requires the 5 costs. So total 25 into 4, which is equals to 100 is the answer. Right, everyone? Do you have any doubts? I hope by now you understand completely what this insertion sort does, right? Now, in a way, if I, yeah, right. So we are done with this problem. Let's go on to the next question. So what will be the output for this program? So we are given some program and we want to find the output. So let's analyze this program and try to answer the questions. Right, we have a standard IO library for input output, right? Now we have defined a macro. Everyone, are you familiar with the concept of macro? What is a macro? So basically, what is a macro? Macro is some alias, some name given to some name given to something that is replaced by the compiler before starting compilation of the program. For example, here we observe this func1. We are defining something like this func1, which takes 2 arguments. What it's replaced by? It is always replaced by this ternary operation, which says if a is greater than b, then return b, else. So basically what it does is it returns the smaller value of the two. So I hope by now you are familiar with the concept of ternary operators, so I don't need to explain how you get this. But essentially what this macro is saying, it says that func1 of a comma b means minimum of, return the minimum of a comma b. Right, everyone? Do you agree with this? So we are trying to solve this, right? We are trying to understand what is happening here. So we are going one by one, right? Func1 of a. So now do you agree? If in any program, if in any step in the program, in any line, if you find a line that says a statement that says func1, so you know what to do there. You need to replace it with this value, with this function. What is the function? Func1 ab is equals to minimum of a comma b. Everyone, do you agree with this? If you have any doubts in understanding this, please type in the chat box. Right, everyone? Can I proceed? It says, so it says func1 of a comma b is equals to minimum of a comma b. Right, everyone? Now again, we have func2. We have another function. I mean, another macro func2. Let's see what it says. Right, yeah. Hmm. So what this func2 does, it again replaces the code section. What it does, func2 of AB is equals to, anyone? Can you understand this question, this segment? What this program is doing? It is swapping. So if you call the swap, this is swapping A and B. What it does, it swaps. So the value of A stored becomes B, stored gets stored in B. The value of B gets stored in the array in the in the variable A. Right? Now let's move on to the program. So now we have established what you have to replace. Whenever we obtain some set of tokens in the program, we have to replace them with some operations, and these are the operations, right? So let's go on to our main function. In the main function, we can see we have integer a contains the value of 3, b contains the value of 5, and we have another integer value temp variable temp. Hmm. Right? Now let's go inside our main function. We have declared some variables here, and a contains value 3, b contains value 5. Now let's see what is going on inside this if statement, right? So we need to analyze what is going here, then only we can proceed with this problem, right? So we need to get the output of this bracket. So we all know how these operations or expressions are evaluated in C. So I hope by now everyone of you is familiar with this expression uh, of precedence, how operators are operated. So we have these brackets. This will be evaluated first. So let's extract this block here and let's see what is happening here. It says 3 plus func1 of a comma b. Now what it becomes? It becomes 3 plus minimum value of a comma b. This is how these macro preprocessors work. Everyone, are you familiar with this? So now what is this? The value of A is 3, B is 5. So what is the minimum of A plus B? A comma B, 3. So it becomes 6, right? So now the value of this block is 6. So what this statement becomes? This becomes if, let me put it like this becomes if 6 is greater than B, right everyone? This is a 6, right? What I'm saying? I'm saying inside the condition statement, I'm saying if 6 is greater than B. So what is the value of B? We know 5. So what is this? This is true. Everyone, right? So when you look at this condition inside the if block, when you extract this conditional statement, you get true. So 6 is greater than 5, which means it's true. Right, everyone? So now you have this condition is true. Now we have established that this condition is true. So this line has to be executed, right? We have to execute this line. Now we have to execute this line. Now let's extract this block, right? We have to extract this expression and let's see what it does, right? So we know func2 a comma b, what it does, swap a comma b, right? By swap, I'm saying just copy the values of a into b, b into a. So now what are the values that we get? This means a becomes b, b is 5, and b becomes a, which is 3. Now finally what we are doing, we are printing the values of a and b. So what you do, you print a and b. So what is the output that you would get? Output on screen, what you would get, a comma b, which is 5 space 3. Now this is the answer. Like, no, you are using percentage d format specifier for integers and you are passing the values a and b. So you get the answer 5 comma 3. Anyone, do you have any doubts in this program? Please type in the chat box. So this question was completely intended for you guys to understand how preprocessor directives work. Now, if you have any doubts, please type in the chat box. I hope you will be able to solve other problems on your own, like problems on these topics, right? Everyone, do you have any doubts? Please type in the chat box for this problem. Otherwise, we can move on to the next question. Yeah, okay, yeah. So there is some issue in this definition, so there is no semicolon here. Now it's correct. Anyone, do you have any doubts now? I guess no one has any doubt. So, guys, let's take a break for a few minutes, for 3 to 5 minutes. I just need to get some water and I'll be back, right? Then, till then, if you have any doubts, please type in the chat box. Right? If you have any queries, please type in the chat box. I'm just coming in a minute, right? Hi everyone, am I audible? So let's resume the session. Someone is asking, how can I know when I have to swap the value? So Palak, am I audible? Should I start explaining? Like I just want to confirm from everyone if everything is fine. If I'm audible and everything is clear, please type in the chat box. Palak, you had a doubt. I am answering this. If I'm audible, please confirm. Yeah, great. So you're saying when you will you know that when to swap the values. So whenever whenever you observe this block func2 a comma b in the program, whenever you observe func2 and you pass in two values, it just means you have to swap those values. So right, like in this program, you find this in this line, right? Palak, is this clear? So you find this func2 is here. So now what you do, you swap the values stored in the past in variables. That's it. So, like, it's not a function. No, this is func1, func2. These are not functions. These are macros. Like, they get in the function, wherever the compiler finds these statements, what it does, it replaces those statements with the block that these macros define. For example, this says func1 a comma b. So it essentially becomes yeah. Let me expand it and write it. How the program will be inferred by the compiler. So how the will be served by the compiler, right? So I'm just writing the part inside the main function. Hmm. So this main function. So you have integer variables a equals to 3, b equals to 5. Now you have if 3 plus. Now, whenever the compiler sees func1 a comma b, what it says, just replace it with the block that is defined in the macro. So if 3 plus, now what is the macro here? A greater than B, then B, else A, right? Now, yeah, if this is greater than B, right? What do you have to do? Func2. It says func2. So what does by func2, what do I mean? You just copy and paste the blocks that define this macro. The blocks are, so you have a variable temp A equals to B equals to temp, right? Now finally what you do? You print the values, printf percentage d space percentage d comma a comma b, right? Now what will be the output of this program? Palak, is this clear? Now just simply compile this program and you will see the outputs. Like this is how macros work, this is how they are useful, right? Great. So let's move on to the next question. Consider an array of elements 5, 4, 3, 2, 1. What are the steps of insertions done while doing insertion sort in this array? So we have already solved this problem a lot of lot number of times. So let's do this once again and let's do this faster this time, right? So I won't be solving this problem very explicitly. I will just show the uh, sorted steps, like in each step whatever we are doing, I will just show that. So you start with the index 0, index 1, and move towards the right, right? So this is how you do insertion sort. Let's solve this problem, everyone. Please follow me. So now you start with index 1. You know you have to swap. So you swap this and your new updated array. So for in the first insertion sort step, your updated array becomes 4, 5, 3, 2, 1, right? And I hope this is clear to everyone, right? What is going on here? So what I did here is I started with the index 0 and I found out the best position for this if the array was sorted, and I put the value 4 at that location. So right, the index was 0, so I swapped those values. So this was step 1. So insertion saw step 2, step 3, step 4. Let's solve this. Now you start with index 2. Now you check index 2. Index 2 value is 3. The correct location is 0. So you put it here and shift all the values towards the 5, right? Now the value 2, the correct position is here, index 0 again. So you get to shift other values 2, 3, 4, 5, 1. Now the value 1, again the correct position as this index 0. So you get 1, 2, 3, 4, 5. So this is the answer. Like, right, everyone? Now you can do this on your own. I don't need to explain this. Fine. And still, if you have any doubts, please go back to the video session and solve this again, and you will get this. Right? I won't be explaining the steps of insertion sort again because I have done it for more than one problems by now. Right? So these are the answers. So let's see which option matches. So 4, 5, 3, 2, 1. 3, 4, 5 to 1, 2, 3, 4, 5, 1, 1, 2, 3, 4, 5. So option A is correct, right, everyone? So you can simply see the option A is correct. Yeah, right? Anyone do you have any doubts? Please type in the chat box. If you have any doubts, please type in the chat box for this problem. I have done this many times for now in this session. So if you have any queries, please type in the chat box for this problem. If you don't have any queries, please confirm by typing the chat box so that I can move forward. Anyone? Do you have any doubts? Please type in the chat box. Please type in the chat box if you find any difficulty in understanding the solution. So no one has any doubts? If no one has any doubts, please confirm once that I'm audible and everything is visible. Then we will start with the next problem. Great. So let's move on to the next question. Now, here's some trick question I wanted to solve with this with your guys. So now we already saw that insertion sort takes order of n square worst case time complexity, right, everyone? In problem 1, we saw this in question number 1. Saw this in question 1, right? Anyone, do you have any doubts with this? So let's be very clear with this, right? What I'm saying, what should be clear with this right now? That insertion sort takes order of n square big O time. Big O means the worst case timing, right? Anyone have, if you have any issues, please tell me right now. So everyone, do you agree with me this that it takes order of n squared? Because I'm going to solve this. I hope everyone is clear because no one is answering, so I'm not sure if you guys the answer was clear or not, but I hope it is clear. Now, now devise the method by which we can reduce this complexity. Okay. So we want to make some changes to our traditional insertion sort algorithm that we all saw right now, and we want to increase reduce the time complexity. So everyone, please pay very careful attention to this problem, how I am approaching this problem, and how I want to sort this, right? So let's say we have a very big array containing 1000 elements, no? Everyone? So just keep answering to me so that I get an acknowledgement that, yeah, this is clear, right? So let's say we were observing at some index X, index K. Let's say we were observing the values at index K, right? So we have indexes 0, 1, 2, 3, 4, and so on up to index 999, right? We have 1000 elements. Now we were observing some index K. We are observing some index. Oh, shit. Uh, Sorry, guys. Hmm. 0, 1, 2, 3, 4. Yeah. So now let's say we are observing some index K. So we are observing this index K here, right? And we are doing the same steps as we were doing in insertion sort. So what we were doing, we were comparing, finding its location in this. So how to find the location? So what is the problem that we solve when we do insertion sort, right? No. Hmm. We are observing some value in the index K, right? Now, what are the steps that we do when we do insertion sort? So, how to find the target index location for value present at index K? Anyone? So you know the answer, how we were doing this. This was our index K. Everyone, please answer. Now I want to find the target location for the value present at index K. How to do this? Please answer this question. How are you doing this? Anyone? So what you were doing? We were doing linear search, right? Yep. So we were doing linear search for finding the element just greater than the element at index K, right? We were doing this. Sravis, you have answered correctly. Yeah, we were comparing with every element. We were doing what we were doing. We were going element by element. So we were doing linear search. Now we all know that this array up to index k minus 1. So this array up to index k minus 1 is already sorted, right? This array is already sorted. The elements are already in ascending order, right? If you are doing ancestor sort to sort elements in ascending, right? Everyone. So do we really need linear search here? Can we do anything else? Can we benefit from it? Uh, Take advantage of this suggestion. Anyone? Yeah, great, Travis. Your answer is right. What we can do instead of doing linear search, what we can do? So we can do binary search, right? Yeah. Now you will see if you do this, it will take order of log n log n. So using binary search with insertion sort and reduce the complexity to order of n log n. Right, everyone? Now can you do this? Is this problem solved? Do you have any doubts in this problem? Is this clear? Is this solution clear? Like we can do binary search here, right? Hmm. But yet again, you will have to shift the values by one index, so it will eventually take up order of log n squared. But yeah, still it's good to use binary search. Why it will still take order of n square? Because you have to swap the values, no, to put it in the right location. So doing that will require, in the worst case, will require again order of n operation. So it will take order of n squared. You can't decrease. We cannot decrease the worst case complexity, but on an average, algorithm will be more efficient, right? Why we can't decrease? Because shifting values will still need order of, right. So this was one problem. Any now, if you have any doubts, please type in the chat box. Right? These were some problems that I wanted to solve for you guys. Now, if you have any problem, please type in the chat box. There are some practice problems that will be shared with this module. You can solve these on your own. Now, if you have any doubts, please type in the chat box. Second answer, yeah. Someone is having doubts on question number two. So yeah, the question is binary search is useful when an array is the options are sorted, unsorted, sorted in ascending or sorted in descending order. So correct answer is it is as useful if the array is sorted, even if the array is sorted in ascending or descending, it doesn't matter. It will be useful if it is sorted in any order, right? So the all three options A, C, and D are correct. Clear, Steven? Yeah, the PDF document will be shared with you guys. So if you have any doubts, you can ask me, or the session is over by my side, right, everyone? So if you have any doubts, please type in the chat box. Otherwise, you may leave the session. Yeah, Stravis wants the code for insertion sort. So let's do this. So let's first think how to write the program, and then we will write the code. Stravis, like, please stay with me on this so that I can solve this. So program for insertion sort. So let's do this. So let's say we have some array, general array, right? We know the steps how sorting is done. So let's write the indexes, index 1, 0, 1, 2, 3, up to index n minus 1, right? We have n elements, so n minus 1. And we want to write a code for insertion sort. Shravesh, anytime you face in difficulty in understanding the program, please tell me, type in the chat box, right? Let's solve the program, solve the problem. So let's say we have an array, integer array, intarr containing this 10 elements, n elements, like, right? Yeah. So we have some integer array that contains these elements, and we have defined n equals to 10. So we have 10 elements, right? and we want to write a program for insertion sort. So let's see how to do this. So we all know the steps, right? So we start for some integer I equals to index 1. So we start from index 1, loop till I is less than n and I plus plus, right? So we start from index 1 and we go up till index n minus 1, right? We start from here and go until here. Now inside this, for each index, what I have to do for, so for index I, so what you have to do, first step, find correct position, right? We have to find the correct position. This is the step 1. So step 1 is find the correct position, and step 2 is place at the correct position, right? Sravirs, this is clear? Sravirs, is this clear? So let's see how to find the correct position. So we have some outline of our program, how the program will look like. Now let's do step 1, find the correct position. So I can do, so I am taking the easy way. I am using linear search. So I'm using linear search for you, and assume that binary search part is a homework for you guys, right? So I am using linear search. Take use linear search and get target index, right? Equals to T. Now, second step, what we need to do? What we need to do? We need to place the value at I. So basically at index I to shift the value at index I to our new index T, right? And this is step 1 for this, and the step 2 is shift all index values from T plus 1 to I by 1 towards right. Right? Is this clear, Sravesh? So this is the algorithm we are going to write a program for. So this is how we design the algorithm. Now let's write the program. I hope this visible. Stop, unity work. So, so .c. So the text is visible, no, Shravir? So hashtag include Yeah, your dot h void main, right? So now we have our main function. Now let's declare our array of length 10, 4, 3, 2, 12. Right? And Tn equals to 10. So we are saying that array size is length. So first what we need to do? Iterate each array index from 1 to n minus 1. So how to do this? For int I equals to 0, I equals to 1, less than n, I plus plus. Right? Now, step one, what we need to do? Find the correct position. Uh, how to do this? Linear search. So let's do linear search. Int target index equals to -1, let's say. Let's assign some random value. Now start iterating through the array. For j, so we have used variable I, so I can use variable j. J equals to I, right? We have to go till the index 0, so j is greater than equals to 0, and we have to decrement j. So j goes minus minus, j minus minus, right? Now we have to find the index j such that the array value at j is just greater than value of j is less than array value at I, right? That will be the correct position. So if arr at I is greater than arr at j, right? So less than, sorry. It will be less than, yeah. Because we are already assuming that the array has been sorted before that, no? If arr at I at arr at j, then you have to do set target index equals to j, and you have to break the loop. You don't need to move further, right? In what do you do in linear search? As soon as you obtain the solution, you end it, right? You end the loop. You don't keep iterating again and again. You get the target index, you use the break keyword to break here, and you get the correct position in the array. Now, step 2. What we have to do? Step, so let's store the value, right? Let's store the value. So int temporary value is equals to arr at I. So we are going to put it the value arr at I at correct location. Step 2. Now what we have to do? Step 2, part 1. What you have to do? Shift the values at index target index plus 2 at indices target plus 1 target index to I by 1 towards right. Right, this is what you want. So how to do this? For int j equals to target index j plus plus, j is less than index I, yeah, right, and then j plus plus. Now what you have to do? You have to shift the values by one index towards the right. What you do? Arr at j plus 1. No. So yeah, how to do this without overwriting the values, no? So um, so you can start from the index I. You again start from the end. Let me tell you what is happening here. So j is greater than I am explaining this step in a minute. J equals to I minus 1. Now plus 1 J right. Now you are shifting the values by one index towards right. Right. Step 2 part 2. Put the value at correct location array. How to do this? Just put ARR at target index is equals to temp val. Right? You have successfully finished sorting algorithm, insertion sort. So now you can print the uh, final values, right? So printf the unsorted, no, yeah, the sorted array is, change the line for int I equals to 0 is less than n I plus plus uh, percentage d space, right? And arr at I, and finally just print, change the line. Okay. So yeah, GDB. Okay. Okay, so mm, Okay, there is some issue in the program. Hmm, One issue. Hmm. So let me just deep. So I will. So this is the idea. The code is a bit confusing and I am doing some mistake here. So I will just explain the algorithm right now and I will just correct the code by myself and then share it to you guys after the session, right? So let me give you an idea what I'm doing. I was trying to do here. So this is what I was trying to do. I was trying to find the correct position using linear search and then placing at the correct position. That's it. And how to shift the values. So let's say you have an array and you want to shift the values from index 0, 1, 2, 3, 4 by 1 towards right, and you have to place something at index. So the value at index 3 goes at index 4, then index 2 goes at index 3, index at 1 goes at index 2, and index 0 goes at index 1. So this is the correct answer. So I will just share the code. You can also look for the code on the internet. I have done some mistake in my program. So yeah, that can be resolved. Right, Srivish? Now, anyone, if you have, so you can leave the session. The session is already over. Hmm. Yeah, thank you all for this session.